This video is about using the factor theorem to factorize cubics and quartics in order to sketch their graphs. We need to be able to use long division with polynomials to factorize cubics and quartics efficiently in order to do this. So the first thing I need to go through is the factor theorem. So we know that if f of a is equal to 0, then x minus a is a factor of f of x. But we also know that if x minus a is a factor of f of x, then f of a is equal to 0 and a is the root, and x is equal to a, and x is equal to a is the root of f of x, or is a root of f of x, is a root of f of x. So this is what the factor theorem is telling us, and it helps us to factorize quartics, cubics, any polynomial really, in order to sketch these graphs. So let's apply the factor theorem to some questions. The first thing we have is f of x is equal to 3x cubed plus 2ax squared minus 4x plus 5a. Given that x plus 3 is a factor of f of x, find the value of the constant a. So if x plus 3, so according to the factor theorem, we know that if x plus 3 is a factor of f of x, it implies that f of minus 3 is equal to 0 by the factor theorem. So let's do f of minus 3. So f of minus 3 is equal to 3 times minus 3 cubed. So everywhere you see an x, replace it with minus 3, plus 2a times minus 3 squared, minus 4 times minus 3, plus 5a must be equal to 0. So that means we get 3 times minus 3 cubed is minus 27, plus 2a times 9, minus 4 times minus 3 gives me positive 12, plus 5a is equal to 0. So I get minus 81 plus 18a plus 12 plus 5a is equal to 0. That means I've got 23a is minus 81 plus 12 gives me minus 69 is equal to 0, which means 23a is equal to 69, which means a is equal to 69 over 23, which means a is equal to 3. So that would be my solution. Next question. Given that x minus 1 and x plus 1 are factors of px cubed plus qx squared minus 3x minus 7, find the values of p and q. So if x minus 1 is a factor of, let's call it f of x, let f of x be equal to px cubed plus qx squared minus 3x minus 7 of f of x, it implies f of 1 is equal to 0. Well, this means that p times 1 cubed plus q times 1 squared minus 3 times 1 minus 7 is equal to 0. This reduces down to p plus q minus 10 is equal to 0, which means p plus q is equal to 10. So that's my equation 1. In a similar way, if we have x plus 1 is a factor of f of x, this implies that f of minus 1 is equal to 0, which means p times minus 1 cubed plus q times minus 1 squared minus 3 times minus 1, take away 7 equals 0, which means minus p plus q, that gives me plus 3 take away 7, which is equal to minus 4 is equal to 0, which means minus p plus q is equal to 4. That's my equation 2. So I've got p I've got P plus Q equals 10 and minus P plus Q is equal to 4. So if I do equation 1 added to equation 2, then I get the P's disappear. All I'm left with is 2Q. 2Q is equal to 14, which implies Q is equal to 7. But if Q is equal to 7, we know P plus Q is equal to 10, which implies P plus 7 is equal to 10, which means P is equal to 3. So our solution is P equals 3, Q equals 7. Okay, so next question. Okay, so it's factorize f of x is equal to x cubed plus 4x squared minus 11x minus 30. Okay, so what we need to do is first is trial and error to find a number that you can substitute into this, which gives you a value of 0. So a hint is always try either plus or minus 1, plus or minus 2, plus or minus 3. One of those should give you a solution. So I'm going to choose, I just feel like because I've got a negative 30 there, it must be a negative value. I think minus 1 is not big enough, so I'm going to go for minus 2. So let's do f of minus 2. So f of minus 2 is minus 2 cubed plus 4 times minus 2 squared minus 11 times minus 2 minus 30. So if I do that, that gives me minus 8 plus 4 times 4, which is 16, plus 22 minus 30. And that does give me a value of 0. Now, since f of minus 2 equals 0, then x plus 2 is a factor of f of x by the factor theorem. Now I need to do a polynomial division to find my other factor. So if I do a polynomial division, so I need to do x cubed plus 4x squared minus 11x minus 30 divide by x plus 2. Now please brush up on your polynomial division if you haven't done it already. So it's just a skill that you need to learn, so practice a few and then you should be better at this. So x times what gives me x cubed? It must be x squared. Then I multiply these out. X squared times x gives me x cubed. X squared times 2 gives me positive 2x squared. Now remember, I'm subtracting these. So I get 0 for the first term. The whole point is the first term always cancels out. 4x squared take away 2x squared gives me 2x squared. I bring the other terms down. X times what gives me 2x squared? It must be a positive 2x. Multiply out 2x times x squared is 2x squared. 2 times 2x is 4x. Again, I'm subtracting these. First term always disappears. Negative 11x take away 4x gives me negative 15x take away 30. X times what gives me negative 15x is minus 15. When I expand it, I get minus 15 times x is minus 15x. Minus 15 times 2 is minus 30. And when I again subtract these, I end up with 0. Now, if x plus 2 is a factor, we want a remainder of 0, so you know you've done it right. So that means x cubed f of x, which is equal to x cubed plus 4x squared minus 11x minus 30 is equal to x plus 2 times x squared plus 2x minus 15. Okay, x squared plus 2x plus minus 15 can be factorized into 2 brackets. So we know the first term in each bracket is x. I want a product of minus 15 and a sum of 2. It must be positive 5 and negative 3. Okay, we were asked only to factorize it, so that is the full answer. So we fully factorized it using polynomial division. There is another way to do this. So this is method A. Okay, method B, there is another method to do this. So this is method B, which is inspection. I've got x cubed plus 4x squared minus 11 minus 30, minus 11x minus 30 is equal to x plus 2 times something. Okay, so what I do in this case is I know x times x squared gives me x cubed, so the first term must be x squared. Now I get x squared, so this and this gives me the correct one. Here I get 2x squared, but I want 4x squared. What do I need to make this, the second term, to make? So I've got x cubed already, and I've got plus 2x squared. But I want from here a positive 4x squared. So what that means is I need to add on another 2x squared. So x times something gives me 2x squared. So it must be a plus 2x. So I'll get a plus 2x. But that means when I expand this, 2 times 2x, I'm getting plus 4x. But I want a minus 11x. So 4x add something gives you minus 11x. That must mean I want a minus 15x. Yeah. So x times something gives me minus 15x. That must be a minus 15. So when I do get the minus 15x, I get 2 times minus 15, which is minus 30, which is what I wanted. So I do end up getting what I want. Okay, so this method is inspection, where you look at what you have when you expand the bracket and then what you need to do to get the terms on the left-hand side. So I did get the minus 30, so it does work out. So the first method is by polynomial division. The second method is by inspection. Okay, fully factorized 2x cubed plus x squared minus 18x minus 9. So again, we have to use trial and error. Okay, the numbers are not that big, so I'm guessing it's going to be a positive number. 1 looks too small, so I'm going to try 3. So f of 3. F of 3 is equal to 2 times 3 cubed plus 3 squared minus 18 times 3, take away 9, which is 2 times 27 plus 9 minus 18 times 3 is minus 54, take away 9. 2 times 27 is 54. 54 plus 9, take away 54, take away 9, which does give me 0, so it does work out. Since f of 3, if it didn't work, by the way, I'll try a different number. Since f of 3 is equal to 0, x minus 3 is a factor of f of x by the factor theorem. Okay, so now I need to do a polynomial division to find my other factor. So that means I need to do 2x cubed plus x squared minus 18x minus 9 divide by x minus 3. X times what gives me 2x cubed? It's 2x squared. 2x squared times x gives me 2x cubed. Minus 3 times 2x squared gives me minus 6x squared. When I subtract it, the first term disappears, which is good. I get 7x squared minus 18x minus 9. X times what gives me 7x squared? It's a positive 7x. So I get 7x times x, which is 7x squared. Minus 3 times positive 7x is minus 21x. Again, we're subtracting the terms, which I end up with minus 18x take away minus 21x, which gives me 3x, and then minus 9. It must be a positive 3 here. 3 times x is 3x. 3 times minus 3 is minus 9. And when I subtract it, I'm getting a remainder of 0, which is what I want. So that means my initial polynomial or cubic that I started off with is equal to x minus 3 times 2x squared plus 7x plus 3, which can be factorized into 2x in one bracket, x in the other, plus 3 in this one, plus 1 in this one. So I've fully factorized it, and now if I'm trying to sketch this graph, I know that my x-intercepts, let's go over here, my x-intercepts are x equals 3, x equals minus a half, and x equals negative 3. My y-intercept, I can read straight away from there, is the constant is minus 9, so y is equal to minus 9. It's a positive cubic graph because the coefficient in front of x cubed is 2, which means that it looks like so. So now if I sketch it out, okay, my y-intercept is minus 9, my x-intercept is positive 3, negative 3, and negative a half. Again, it starts from third quadrant and goes up to what, the first quadrant. So something like, oops, make sure it's going through 9. 9 minus 9, sorry. And that would be it. Okay, next question. So f of x is equal to 3x cubed minus 12x plus 6x minus 24. Use the factor theorem to show that x minus 4 is a factor of f of x. So x minus 4 is a factor, so if I substitute f of 4 in, then 3 times 4 cubed minus 12 times 4 squared plus 6 times 4 minus 24 is 3 times 64 minus 12 times 16 plus 24 minus 24. 3 times 64 is 192. 16 times 12 is 192 plus 24 minus 24, which gives me 0. So since f of 4 is equal to 0, x minus 4 is a factor of f of x by the factor theorem. Hence show that 4 is the only real solution of the equation f of x equals 0. So let's do a polynomial division now. So x minus 4 divide by 3x cubed minus 12x, so divided into, plus 6x, take away 24. So it must be a 3x squared here. So I get 3x cubed minus 12x squared. So we're subtracting it. So first term disappears, but also the second term disappears. So I just get 6x minus 24. X times what gives me 6x? It must be a positive 6. 6 times x is 6x. 6 times minus 4 is minus 24. When I subtract it, I'm left with 0. So that means f of x is equal to x minus 4, which was my first factor, times the quotient that I got at the top, which is 3x squared plus 6. So if I want to find another solution, x equals 4 is already a solution, but if I want to find another solution, it's when 3x squared plus 6 is equal to 0. So 3x squared plus 6 is equal to 0 implies that 3x squared is equal to minus 6, which implies x squared is equal to minus 2, which means x is equal to plus or minus root of minus 2, which has no real solution, because we can't square root a negative number. okay, which has no real solutions. Therefore, x is equal to 4 is the only real solution. Show that x minus 2 is a factor of this quartic. Okay, so if x minus 2 is a factor, then I need to substitute f of 2 in and show that is equal to 0. So f of 2 is equal to 9 times 2 to the power 4 minus 18 times 2 to the power 3 minus 2 squared plus 2 times 2, which is equal to 9 times 16 minus 18 times 8 minus 4 plus 4. 9 times 16 is 144. 18 times 8 is 36, and to 144 again. Minus 4 plus 4, which is equal to 0. So since f of 2 is equal to 0, x minus 2 is a factor of f of x. We should say that f of x is equal to 9x to the power 4 minus 18x cubed minus x squared plus 2x by the factor theorem. Hence, find the 4 solutions. Okay, so I need to do a polynomial division. So x minus 2 being divided into 9x to the power 4 minus 18x cubed minus x squared plus 2x. So x times what gives me 9x to the power 4? It's 9x cubed. When I multiply that 9x cubed times x minus 2, I get 9x to the power 4 minus 18x cubed. Okay, remember we're subtracting these two lines. So I end up with the first term disappearing and the second term disappearing. So all I'm left with is minus x squared plus 2x. Okay, x times what gives me minus x squared? It's minus x. So I get minus x times x, which is minus x squared, minus x times negative 2, which is plus 2x. Again, I'm subtracting these terms. When I subtract these terms, I'm left with 0, which is what I want. So that means 9x to the power of 4 minus 18x cubed minus x squared plus 2x is equal to x minus 2 times 9x squared minus x. I could take a factor of x out, so I get x times x minus 2 times 9x take away 1. So all I've done is the second bracket I divided, took the x out. 9x cubed, was it? 9x cubed, yeah, sorry. 9x cubed, let's write that properly. 9x cubed, so I factorize the x out. 9x squared take away 1 is a difference of 2 squares. So I factorize that to 3x minus 1 times 3x plus 1. So once that is factorized, the solutions are x equals 0, x equals 2, x is equal to a third, and x is equal to a minus a third. So that would be it. Okay, now you can use a calculator to help you to factorize these questions, but just be very careful. When you use a calculator, you need to go to first menu and then select A, which is, I think, equations. This is equation of functions. Then select 2, which is polynomials. Then select the degree, which is 3. Select degree 3, because in these questions they're all cubic, so degree is 3. Okay, so if you input this into your calculator, once you've done all that, it's polynomial and degree 3, then you need to write here. So A is equal to 1, B is equal to 4, C is equal to negative 11, and D is equal to negative 30. And when you do that, So 1, 4, negative 11, and negative 30. It gives you your first solution is, the solution is x. So the calculator spits out these solutions, which is x is equal to 3, x is equal to negative 2, and x is equal to negative 5. So if you pressing equal button, you get all the solutions, which means f of x must be equal to x minus 1 times, f of x must be equal to, because x equals 3 is the solution, it must be x minus 3 by the factor theorem. X plus 2 is the second factor, and x plus 5 is the third factor. Now this one's easy. You don't have to do any adjusting, because if you multiply out the x's, you get x cubed. And if you do minus 3 times 2 times 5, you do get minus 30, which is the last term. So it does work out. So the first case is a simple case where it works out. Now in the second case, when you put a is equal to 120, c is equal to minus 70, b is equal to minus 70, c is equal to minus 55, and d is equal to 30. Put that into your calculator, it spits out these three solutions. So x is equal to negative half, x is equal to 3/4, and x is equal to a half. I didn't get that right, sorry, I'm writing the wrong value. It gives x is equal to minus 2/3, x is equal to 3/4, and x is equal to half. Now that most students would write then, and that means by the factor theorem, x plus 2/3 must be a solution, x minus 3/4 must be a solution, and x minus a half must be a solution. But if you multiply out the constants, you'll see you won't get this 30. So that can't be right. So what you need to do is you just think, okay, I don't like these fractions everywhere. So I'm going to multiply this bracket by 3 to get rid of the denominator at the bottom. I'm going to multiply this bracket by 4 to get rid of the denominator in the bottom for the second fraction, and times this by 2. So when we do that, we end up getting f of x is equal to 3x plus 2 for the first bracket, 4x minus 3 for the second bracket, and 2x minus 1 for the third bracket. Now if I multiply out some of these things and check it, let's see if it works out. Does 3x times 4x times 2x, does it give me the 120x cubed that I want? 3x times 4x times 2x gives me 24x, which is not right. What do I need to do? I need to multiply this by 5, because I want 120x. 24 times 5 gives me 120x cubed. So that means f of x must actually be 5 lots of 3x plus 2 times 4x minus 3 times 2x minus 1. Let's check the last term to make sure it's right. So in the last term, I'd get 5 times 2 times negative 3 times negative 1. That gives me 10. 10 times 3, which is 30. Is the last term 30? Yes, it is, so it works out. So my final answer will be this one, will be f of x is equal to 5 lots of these terms. And let's look at the last example. So in the last example, I've got, so in this case, A is equal to 1, B is equal to 5, C is equal to 11, and D is equal to 15. So when I put this to my calculator, my first solution is minus 3. My second solution is equal to minus 1 plus 2i. And that means it's not a real solution. So I need to cross, I don't know that solution in this. In the A-level course, we don't deal with imaginary numbers. And the next one is x is equal to minus 1 minus 2i. Again, an imaginary solution, so we cross that out. So that means we have only one real solution. So one real solution. So in order to factorize it, because we only know one real solution, we just need to do a polynomial division. So if x minus 3 is a obviously solution, it means also that x plus 3 is a factor of f of x, which means I need to do x plus 3 divided into x cubed plus 5x squared plus 11x plus 15. That means x times x squared gives me x cubed. If I do a subtraction now, I get 5x squared take away 3x squared, which gives me 2x squared plus 11x plus 15. X times 2x gives me 2x squared. So I'm getting 2x squared here. 3 times 2x is 6x. If I do the subtraction, I end up with 5x plus 15, which means I need to do 5 times x to get 5x. 5 times x is 5x. 5 times 3 is 15, which gives me a remainder of 0, which is what I wanted. Which means I can write f of x as x plus 3 times x squared plus 2x plus 5. And I know that x squared plus 2x plus 5 does not factorize further because there are no other real solutions. So I'd leave it as 2 brackets, a product of 2 brackets rather than 3. Okay, the last bit is all about just remainders when you divide, just so you can see how that works. So because it might come handy when you do integration later on. So we've got f of x is equal to 10x cubed plus 43x squared minus 2x minus 10. Find the remainder when f of x is divided by 5x plus 4. So 5x plus 4 divided into 10x cubed plus 43x squared minus 2x minus 10. So this is the divisor. Okay. So 5x times what gives me 10x cubed? It is 2x squared. So when I do 2x squared times 5x, I get 10x cubed. 4 times 2x is 8x squared. And I'm subtracting these to see what I'm left with. So the first term always disappears, or else I've done something wrong. 43x squared take away 8x squared gives me 35x squared. Bring the other terms down. 5x times what gives me 35x squared? It must be plus 7x. So 7x times 5x gives me 35x squared. 4 times 7x gives me 28x. Now I'm subtracting it again. When I subtract it, the first term again disappears. Minus 2x take away 20x is minus 30x take away 10. 5x times what gives me minus 30? It's minus 6. So I get minus 6 times 5x, which is minus 30x. Minus 6 times 4 is minus 24. Again, I'm subtracting. The first term disappears. Minus 10 take away minus 24 gives me positive 14. So I can't do anything more with this. So this is what I call is my quotient, the thing at the top, and this is my remainder. So that means when I do 10x cubed plus 43x squared minus 2x minus 10 all over 5x plus 4. That means my quotient, which is my whole part, is 2x squared plus 7x minus 6 plus my remainder, which is 14, over what I divided by, which is my divisor, which is 5x plus 4. So this is quotient is always my whole part, which is here. My remainder is this part. So in this question, they only ask for my remainder. So my remainder is just 14. Okay, find the remainder when x cubed plus 6x squared plus 5x minus 12 is divided by this one first. So so it's x minus 2 divided into x cubed plus 6x squared plus 5x minus 12. X times x squared gives me x cubed minus 2x squared. I'm subtracting it. The first term disappears. I end up with 8x squared plus 5x minus 12 plus 8x, because 8x times x gives me 8x squared. So I've got 8x squared minus 16x. Again, I'm subtracting. Oops, undo, subtract. 5x take away minus 16x gives me 21x take away 12. X times what gives me 21x is a positive 21. So I get 21x. 21 times minus 2 is minus 42. Again, I'm subtracting these terms. So I end up getting minus 12 take away negative 42, which is 30. And I can't do any more, which means my remainder is equal to 30. Part 2, I'm doing the same thing, but I'm dividing now by x plus 3. So x plus 3 divided into x cubed plus 6x squared plus 5x minus 12. Okay, which means I need to do x times what gives me x cubed is x squared. 3 times x squared is 3x squared. Subtracting, first term disappears. I'm left with 3x squared plus 5x take away 12. X times what gives me 3x squared? It must be 3x. 3x times x is 3x squared. 3x times 3 is 9x. Again, I am subtracting. When I subtract, I get 5x take away 9x, which is minus 4x take away 12. X times what gives me minus 4x is minus 4. So when I expand it, minus 4 times x is minus 4x, and 3 times minus 4 is minus 12. And when I subtract it, in this case, I'm left with 0. So the remainder is equal to 0. B, hence or otherwise, find all the solutions to the equation x cubed plus 6x squared plus 5x minus 12 equals 0. Now, since B, since x plus 3 gives me a remainder of 0, then x plus 3 is a factor. Okay, which means x cubed plus 6x squared plus 5x minus 12 can be written as x plus 3 times x squared plus 3x minus 4. But the second bracket is a quadratic which can be factorized. So it's plus 4 and minus 1, which means solutions are x equals negative 3, x equals negative 4, and x equals 1.